What are anonymous types in C#? Anonymous types in C# are a way to create a new object with read-only properties without having to explicitly define a class. They're very handy for when you need a quick one-off type for storing a set of values, especially when doing data manipulations or working with link queries. Let's create our first example. I'm going to create a new class called employee, and we're going to have several properties. We're going to have a name, we're going to have an email, and salary, which is a decimal. And now I'm going to create a list of employees. Inside our main method, we're going to create an anonymous type and simply print to screen the name and the email for each one of our employees. So let's do that quickly. We're going to call this name and email report equals. I'm going to use the query syntax, but we can also use the method syntax. So let's do that quickly. From E in employees, we can select new, and we're going to create our anonymous object. And we're going to get the name and the email, and then I can iterate over our name email report. So for each var item in name email report, and now let's print it to the console. Yeah, this is item. Okay, so let's print name, item name, and we had email, item email, and now let's run the code. And we have name Susan, email susan@example.com, and name Bob with email bob@example.com. And now let's take a look at our code and see what is actually going on. In our code example, this part right here is the part which creates an anonymous type for each employee in our list employees. And this anonymous type has only two read-only properties, name and email. And then we can iterate over our name email report and print the name and the email for each one of the employees. If you're not familiar with the query syntax, you can obviously use the method link syntax, which I guess is more common. So let's do that just to show that you don't have to use the query syntax. So we're going to use the same variable name, and it is going to be employees select, and then we're going to have the same new name and email. So again, we are creating an anonymous object right here with two read-only properties, which are name and email. And again, we can iterate over our name email report and we're going to get the same result. So let me run the code, and we have Susan with email Susan as example, and Bob with email bobexample.com. So each one of the syntaxes actually works. You can use the query syntax, or you can use the method link syntax. And obviously right here you don't really have to use an anonymous type. You can use our employee class. So why would you want to use anonymous type, and when you might want to use a class? So let's quickly see what the difference is and what the advantages of using an anonymous type are in C#. Let's quickly take a look at anonymous type versus traditional class. You can pause the screen and read all the text. I'm just going to mention some of the main characteristics of the anonymous type and when you might want to use it in your code. The anonymous type is perfect for local scope within a single method. It's also ideal for temporary use, especially for single operations or transformations. And the anonymous type is immutable, which makes its properties read-only, and this prevents accidental changes. It can also make your code simpler and easier to read. So let's quickly take a look at some more examples when you might want to use anonymous type in C#. Okay, now let's take a look at the second code snippet that I'm going to use in this video, which demonstrates the characteristics of the anonymous type. The first one is that the properties are read-only. The anonymous types are immutable. Let me actually comment the rest of the code for now. Okay, first we create an anonymous type with two properties. The first one is name, which is John, and the second one is age, which is 35. And we can actually try to modify the properties. So if I uncomment this line here, we're going to see an error which says that the name cannot be assigned to, it is read-only. So this is one very important characteristic. This is why using the anonymous types, sometimes it makes sense, since the properties are read-only and you cannot change them by accident. So let's take a look at the rest of the code. For each anonymous type that you create, the compiler actually generates a unique name, and if you create another anonymous type with the exact same properties, these two types should be the same. We can actually compare them, so let's do that next. We can print the type of our anonymous type 1, and we can print the type of our anonymous type 2, and then we're going to print to the console whether these two are of the same type, which is the expression right here. And in our case, this should return true, since we have two anonymous types with the exact same properties, name and age. So let's run the code and see if this is what is shown on the screen. You can see that this one here is the compiler generated anonymous type, and the number 2 here indicates that it has two properties, and these two properties are actually string and integer. And we can see that this type for anonymous type 1 and the type of the anonymous type 2 are actually the same, which is why our statement right here evaluates to true, and this means that these two are of the same type. And now we're going to actually create another anonymous type, which is going to have the same type of properties, but with different names. So instead of name and age, we're going to have two properties called first name, and let's make this one actually age, and see if the anonymous type 1, which has two properties, name and age, and the anonymous type 3, which has two properties, first name and age, if they are actually of the same type. So let's run the code and see. Let me just comment this out for now. We don't need it. Okay, let me actually delete it. So we are checking if these two anonymous types 1 and 3 are the same, and this is the expression that compares them. So let's run the code, and as expected, we have two different anonymous types. Again, this is the name generated by the compiler, and for each different anonymous type, it's going to generate a different name. And even though they have the same type of properties, string and integer, they are actually not the same. Why? Because we have the first one property here for anonymous type 1 is name, and the first property for the anonymous type 3 is actually first name. So these two, anonymous type 3 and anonymous type 1, are not the same. The next line of code shows that you can actually create an array of anonymous types. You can see I create an array with two items. The first one, we have name Susan, age 24, and the second item is name Alan and age 32. Another characteristic of the anonymous type is that it can be cast only to an object. So let's quickly demonstrate that and see what that actually means. Okay, let me go ahead and create my employee class with two properties. Public string name, and we're going to have age, which is going to be an integer, and we're going to create one employee, which is going to be employee equals new employee with name Alan and age 27. And now we're going to create our anonymous type, employee equals new, and we're going to use the employees properties and age. Okay, and now let's see if we can actually cast anonymous employee to employee, and let's try to do that and see what happens. We're going to go cast employee equals employee, anonymous employee, and you can see that we cannot do that, and we get an error which says cannot convert type, anonymous type, string, whatever, to program employee, which means we cannot cast our anonymous employee to employee even though we have the same properties, and the anonymous types can be cast only to objects. So let's demonstrate that quickly. I'm going to go object equals anonymous employee, and you can see that we don't get any compiler error, and you can actually print this to screen and show that we managed to cast our anonymous employee to object, cast to object, and let's print the compiler generated name for our anonymous type, get type. And if we run this, we're going to see cast to object, and this is the compiler generated name for our anonymous type. So this is another thing to remember, that you cannot cast anonymous type to anything else other than object. And the last thing I actually want to mention when it comes to anonymous types is that the toString method is actually overridden, and let's see what happens if I try to use the anonymous employee to string. So let's see what is going to get printed to screen. Console, right line, and let's go to string. So let's run the code, and you can see that we actually have the properties of the anonymous type concatenated and printed to screen. So the toString method is overridden in the anonymous type. And this is all for me for today. If you like my videos, hit the like button and subscribe to my channel. Thank you for watching.